Welcome to our tutorial about digital clipping. In this tutorial, we're going to learn what digital clipping is and talk about how you can prevent it in your work. Basically, you want your input to be as loud or hot as possible without clipping. What exactly is digital clipping and why is it so nasty and irreparable? A digital recorder reads up to 0 dBFS. That's 0 decibels full scale. 0 dBFS means that all the bits are used, whether you've selected 16 or 24-bit depth. Basically, 0 dB is the loudest value that your computer can record. Digital audio can't express a number above 0 dB. This means if you try to record a signal whose amplitude goes above this maximum value, there's no way to express that loud of a signal. Your computer works hard to do the best it can, though, and it reproduces a string of 0 decibel values, which wind up looking like this flat top you see here. The resulting sound is a buzz or a distortion that's unbearable. So generally, when you go above 0 dB on your meters, you're entering the zone of digital clipping, and there really isn't any way to fix that later. There's some exceptions. If the clip is less than 5 samples long, for example, you can usually modify it manually. Just zoom in real close and change the shape of the wave. Also, sometimes clipping on the input's okay. You just need to have a listen to see what's happened. However, clipping on your output meter will be trouble. When you're setting your levels, make sure that the meters on your software's input aren't going into the red, which is usually an indication of clipping. If they are, turn them down, turn down your source device until it's no longer going into the red. But since audio interfaces vary, do a test recording and then have a listen also. One manufacturer may allow signals, especially peak signals or transients, to go into the red without introducing distortion, while another device might clip when signals barely hit the overload indicators. Generally, you don't want your levels to be so hot that you don't have any headroom to make adjustments later on, like with volume maximizing or EQ that might drive up the levels of certain frequencies in the recording. You need to leave a little space for these adjustments. One thing not to do when you clip is turn down the output in the software or on your output device so that you don't hear it. This is only going to give you softer clipping because the source of the clipping problem is on the input. Be careful not to record too soft a signal in fear of clipping. If the signal is too low, then you get a less accurate representation of the audio in digital form. It's going to be grainy, thinner. That's an inevitable part of the digitizing process, whereby the audio signal gets converted into numbers. If your input is soft, the sound is going to be represented by fewer zeros and ones than if it's louder, so the quantization error will result in a much more inaccurate representation of your sound. Louder levels will be represented by higher numbers, so the resulting sound will be more full, more accurate. That's why it's important to set your levels carefully before you get started. Your output, despite whatever amazing plugins that most DAWs lay at your fingertips today, is only going to be as good as your input. And this concludes our tutorial about digital clipping. In our next lesson, we're going to talk about dithering.